Given the equation for a linear function, we're going to graph the function using the y-intercept and the slope. Step 1, evaluate the function at an input value of 0 to find the y-intercept. Step number 2, identify the slope as the rate of change of the input value. 3, plot the point represented by the y-intercept. 4, use rise over run to determine at least 2 more points on the line. And number 5, sketch the line that passes through the points. So for example 12, we're graphing by using the y-intercept and slope. Graph f of x, which is equal to negative 2/3 x, plus 5 using the y-intercept and slope. So because this is in slope-intercept form, we can determine what is the y-intercept and the slope by looking at the equation. Now also notice that we have a negative in front of them 2/3, which means that we're going to have a decreasing slope. So it's always important to identify this information before you start moving ahead. Now, if you notice now, with the equation, the slope m is equal to negative 2/3, and 5 is going to be our y-intercept, which is 0, 5. So again, evaluate the function at x equals 0 to find the y-intercept, and the output value when x is 0 is 5. So the graph will cross the y-axis at 0, 5. And now, according to the equation for the function, the slope of the line is negative 2/3. This tells us that for each vertical decrease in the rise of negative 2 units, the run increases by 3 units in the horizontal direction. We can now graph the function by first plotting the y-intercept on the graph in figure 13. From the initial value, 0, 5, we move down 2 units and to the right 3 units. And we extend the line to the left and right by repeating and then draw a line through those points. Okay, so first, we're identifying the y-intercept. Okay, which is noted here at 0, 5. Okay, and so then what we know is that we have negative 2 over 3. So that means we're going to go down 2 and then to the right 3 to get our next order pair. And then again, down 2 and then to the right 3 to get our next order pair. Now, this also equals the following. We can also say that the numerator 2 is positive and the denominator is going to be negative, because ultimately it's going to give us negative 2/3. So if we take a look at our ordered pairs, our points, okay, we can see that we can then go up 2 and then to the left 3. Up positive 2 and then to the left of 3. Because again, what that means is that we have a negative slope entirely. So the graph slants downward from left to right, which means it has a negative slope as expected.